Assalamualaikum and hi everyone. So in this video, I'm going to show you about the Laplace transform, the overview of our chapter 4, the Laplace transform. Okay, based on our discussion during our synchronous class, okay, we have discussed about the Laplace transform. So what is Laplace transform? So what is our main target? So in this video, I just repeat what we have discussed previously. Okay, and I hope that this video can enhance your understanding about what is the Laplace transform, because I don't want to see once again that you write down your name as fail mathematics sucks ke, and then mathematics susah ke. So I don't want to see it anymore. Okay, so please make sure that kita reset our mindset, okay, and we say that engineering mathematics 2 is an easy course, okay, for you to score. Okay, so for the chapter 4, right? Oh no, this one is chapter 3. Okay, so our chapter 3, okay, is the Laplace transform. Alright, so what is Laplace transform? So Laplace transform is a method, okay, it's a method to, we can say in our course, Laplace transform is a method to solve for initial value problem. If you still remember, during our chapter 1, okay, and chapter 2, we have discussed about first order linear differential equation, okay, and then for chapter 2 we discuss about second order linear differential equation, while in chapter 1 we discuss about 4 types of equation. Okay, chapter 2 we have 2 methods to solve for the non-homogeneous, okay, linear differential equation with constant coefficient, and then we talk about the Cauchy-Euler equation. Okay, how the second order linear differential equation with variable coefficient, the Cauchy-Euler, okay, Cauchy-Euler can be transformed into the form of constant coefficient. Then we apply the 2 methods, okay, 2 methods to solve the differential equation. We call the method as undetermined coefficient method and variation of parameters method. Okay, so if you still remember, during our chapter 1 and chapter 2, we discussed about the general solution and the particular solution. Remember, okay, the general solution and the particular solution. In order to get the particular solution means that the question, okay, your differential equation must attach together with the initial boundary condition. Okay, so that you will have either initial value problems, okay, or you will have boundary value problem. For first order, you must be given one initial condition, so that you will have when you have differential equation comes together with initial condition, so that we need to solve for the IVP. Okay, second order, you must be given 2 initial conditions. Okay, so when you have 2 initial conditions, so that you are dealing with initial value problems. Okay, if you are given boundary conditions, means that you try to solve for boundary value problem. Okay, the same thing in the Laplace transform. Okay, at the end of the course, okay, at the end of this topic, actually we want to solve for initial value problem. When we talk about initial value problems, means that we must be given a differential equation, and this differential equation must come together with initial condition. So in short, what we can say is we try to find a particular solution. In short, we can say that we try to learn an alternative method. For me, I think that the Laplace transform is more powerful compared to the method that we have learned in chapter 1 and chapter 2. It is according to our problem, the difficulty of the equation that you have. Okay, so let's talk about the Laplace transform. Okay, the Laplace transform, okay, is a method that actually we try to find the transformation of a function in time domain. We call it as f of t. T stand for the time domain. Okay, the function in time domain, we call it as ft. It can be gt, it can be anything, okay, as a function of t. And then we try to find the transformation into another function where the function that we transform from the time domain is equivalent, okay, setara, okay, or similar to the time domain. We call it as complex frequency domain. Okay, normally the complex frequency domain, after you do the transformation, it is depends on your the previous function in time domain. If your function in time domain is ft, so that your complex frequency domain is capital Fs. If you are given gt, small g, as a function of t, so that your complex frequency domain is capital G of S. Okay, so in order to get this transformation, class, we need to find the process is the Laplace transform. Okay, you try to transform the time domain by using the Laplace here. Okay, then you get an equivalent function. We call it as f of s, complex frequency domain, and this L we call it as Laplace operator. Okay, we have discussed about this L during our class, so that I hope that you remember, okay, about the operator. Okay, so basically in our class we try to discuss, okay, time domain. We want to transform in complex frequency domain. The question is how? So by taking the Laplace of time domain, you get complex frequency domain. Okay, let's say you are given initially you are given in complex frequency domain. How you can get the equivalent function in time domain? How to get ft back? How to get ft? What you need to do is you need to take the Laplace inverse both sides of your function. Okay, we try to prove this one. Okay, taking the Laplace inverse of fs, you will get Laplace inverse and Laplace gone. So what's left? You just only have ft here. Okay, so in short, what I can say, from time domain to complex frequency domain, the process involved is, okay, so if I can write here is like this. Okay, from ft, okay, to fs. You are given ft. In order to get fs, what you need to do is you need to take the Laplace transform of this one. Okay, but if you are given fs, complex frequency domain, you want to find out what is your ft, what you need to do is you need to take the Laplace inverse of fs, then only you will get ft. So that is the idea. Okay, so in short, in the Laplace transform, what we are going to discuss is our main target here is, simpan dalam kepala kita, okay? Bear in mind that our main target is, our aim is we want to solve for initial value problems. Okay, before we solve for initial value problem, we must learn first what is Laplace transform, what is inverse of Laplace transform. The combination of these two, okay, knowledge will lead to the successful of finding or solving the initial value problems. So let's take a look at what content, what are the things that we will discuss in Laplace transform. In Laplace transform, we will learn about, probably I forgot to write down here. Okay, so first is by definition. We already discussed about definition, right? Okay, so definition. Okay, and then we try to compare with the table of Laplace transform. Okay, definition and table, and then we discuss about the properties. Okay, what are the properties involved in Laplace transform? Only 3 properties. Okay, linearity, first shift, and multiplication by t to the n. We move to the inverse Laplace transform. In inverse of Laplace transform, we will learn about the properties. Okay, the properties also. Okay, by definition is actually we already discussed in general okay, like this. So just to give you the basic idea of Laplace transform and inverse of Laplace transform here. Okay, so in detail we will discuss about the properties of inverse of Laplace transform. Just now properties of Laplace transform, but now is properties of inverse of Laplace transform. What are the properties? Linearity, just the same thing as we have here, so that we will learn after this the opposite. Okay, so kalau kita belajar yang ini, we will learn about the opposite of this one. So senang lah nanti kan. Okay, and then we look at the first shift property at this time for inverse of Laplace transform, and then this one is multiplication by t to the n. So this one is we try to solve by using partial fraction. Okay, the combination of these two things will we apply in order to solve for initial value problems. Okay, so in the next video I'm going to show you about the definition and inshallah about the table, and then we try to move on to the properties. Okay, thank you class.